everyone. Hope you all are safe at home. Now we are going to start examples on simple stress and strain. In previous lecture we have understand about the what is stress, what is strain, Hooke's law, elasticity, each and everything. So based on that, now we are going to start examples. So first example, a circular rod of diameter 20 mm and 500 mm long is subjected to a tensile force of 50 kN. The modulus of elasticity for steel may be taken as 200 kN per mm square. Find stress, strain and elongation of the bar due to applied load. What we are going to find over here, stress means sigma, strain means elongation delta L, epsilon strain. So which are the data given? The diameter of the bar 20 mm, length of that bar 500 mm. For tensile load P is equal to 50 kilonewton. So here they have given us E, modulus of elasticity 200 kilonewton per mm square. But for the calculation we must have to convert all the units in smaller unit, means Newton per mm square. So here 200 into 10 raised to 3 Newton per mm square. Now area of this circular bar is pi by 4 into 20 square. Diameter of this rod is 20 mm. So 314.15 mm square. Now we are going to apply tensile force on the bar, that is 50 kilonewton. So stress is equal to sigma upon A. We have equation, and P is equal to 50 into 10 raised to 3 divided by area that we have finding out just 314.15. So we will get stress, and unit of this stress is Newton per mm square. Now we have equation E is equal to sigma upon epsilon. So we have E and we have sigma. So we can calculate epsilon from this equation, sigma upon E. So it is 7.96 into 10 raised to minus 4. Strain is unitless. It doesn't have any unit. Now elongation. Elongation delta L is equal to epsilon into L, or else we have equation for prismatic section, that PL upon A. We can calculate from any one of them. So we will get 0.398 mm. Now we can judge that whenever we are going to apply load on the bar, we will get this much elongation of that bar. Another thing, a rod of 1 meter length and 20 mm by 20 mm its dimension is subjected to an axial pull of 10 kilonewton like this. If the elongation of rod is equal to 0.12 mm, here delta L given, find the value of modulus of elasticity. We have to finding out the value of E. So length is equal to 1000 mm, area 400 mm square, P 10 into 10 raised to 3 Newton, and delta L we have. So put all the equations. First of all, stress P upon A is equal to 10 into 10 raised to 3 by area. So 25 Newton per mm square. Now strain is equal to delta L upon L. So we will get the epsilon 0.00012. So 120 into 10 raised to minus 6. Clear? Now we have equation E is equal to sigma upon epsilon. So we will get value of E from the equation 208 gigapascal. Another case, a load of 10 kilonewton is to be raised with the help of steel wire. Find the minimum diameter of the wire if the stress is not to exceed 80 Newton per mm square. Here maximum stress, that is 80, not to exceed means maximum. Load 10 kilonewton, so 10 into 10 raised to 3 Newton. Sigma they have given 80 Newton per mm square. So from this to we can calculate, we have equation sigma is equal to P upon A. So we will get some area. Now the wire, and wire having always a circular section. So area is equal to pi by 4 d square. So we have the area, that is 120 mm square. So we will get the diameter is equal to 12.61 mm. It is very much simple. Next case, the ultimate tensile strength of a mild steel is 200 Newton per mm square. Strength, it's a stress. So stress is given over here, that is 200 Newton per mm square. A tie bar of equal leg angle section has to carry an axial pull of 150 kilonewton. Decide the suitable dimensions of the section. If the mean thickness is 10 mm, take the factor of safety as 2. What they have given over here, that is sigma stress 200 Newton per mm square. P load is equal to 150 kilonewton. But whenever we are going to design any section, we must have to take in consideration that factor of safety. So here load must be multiplied with factor of safety. So we can design the section which is little bit safer side. Now sigma is equal to P upon A. So we will get some area from this equation, and that is 1500 mm square. Now we have to finding out the dimension of this angle section having 10 mm thickness. So equal leg angle having this length is L, this length is also L. So if we are going to take two part, then this vertical height is equal to L minus 10. We have to minus this thickness. So this is L minus 10. Now the area of this section, that is this is L minus 10 into 10 first part, and second part is L into this much thickness. This is part 2. Now we have the area, that is 1500, and we can solve this. It's a 10 minus L minus 100 plus 10 minus L. So total 20 minus L is equal to 1600. So length is equal to 80 mm. Now we can provide this angle section having 80 by 80 by 10 mm. What is factor of safety? Here we have considered that is factor of safety as a 2. But why? Why we are going to take factor of safety? Because whenever we are going to design anything, then whenever we have some load, but in some cases that load may be increased in a future. That's why we are considering factor of safety. If the load is increased by 2 times, then and then our section or else our design must be become safer. Clear? Next case, a short timber post of a rectangular section has one side twice the other side. It contracts by 0.005 centimeter per meter when loaded axial by 10 kilonewton. Means this is our elongation, or else contraction, means it is delta L. And load they have given, that is 10 kilonewton. Calculate the sectional dimension. We have to finding out this dimension. E is equal to 0.1 into 10 raised to 5 Newton per mm square. The most important thing that they have given us one side twice the other, means B is equal to twice the D, that we can consider. So here we have epsilon is equal to stress upon E is equal to stress upon epsilon. So stress is equal to E into epsilon, and epsilon they have given, that is 0.05 Newton into 10 raised to minus 3, and E they have given. So here sigma, that is 0.5 Newton per mm square. Now sigma is equal to P upon A. So A is equal to P upon sigma. So area is equal to 20,000 mm square. Now area is equal to B into D, but B is equal to twice the D. So here we will get 20,000 is equal to 2D square. So D square is equal to 10,000. So D is equal to 100 mm, right? So B is equal to 2D. Now we will get the dimension. Depth is equal to 100 mm and width is equal to twice the depth, that is 200 mm. This is our most important thing. An MS bar having 1 meter length and hollow circular section with internal diameter 3/4 of external diameter. The axial compressive load acting on it, that is 100 kilonewton. If the ultimate compressive stress 300 Newton per mm square and E is equal to 200 GPa. Determine external and internal diameter of the section. Also find change in length, means delta L. Here we have two tasks. First we have to finding out the external diameter as well as internal diameter. The another thing, that is change in length delta L, also we have to finding over here. So what the dimensions we have and what data we have, that is P is equal to 100 kilonewton. Compressive stress means sigma is equal to 300 Newton per mm square, and E we have 200 GPa. So D is equal to 3/4 of external diameter. So small d is equal to 0.75 capital D. P, that is 100 into 10 raised to 3 Newton. Sigma is equal to 300 Newton per mm square. E is equal to 200 GPa, means 2 into 10 raised to 5 Newton per mm square. This conversion that we have to always done, and that we have understand in our first lecture of Mos. Here length, that is 1 meter, is equal to 1000 mm. Now sigma is equal to P upon A. So area is equal to P by sigma, that 333.33 mm square. Now area of the hollow section, that is pi by 4, capital D square minus small d square. So from this equation we will get capital D square is equal to 970.56 mm square. Here we have to put small d is equal to 0.75 d square. So now using of calculator we will get d is equal to 31.15 mm. So small d is equal to 23.36. Now we have both the diameter, external as well as internal. Now the equation that is change in length means delta L, and equation of this delta L is equal to PL upon E. So P is equal to 100 into 10 raised to 3, length is equal to 1000 divided by area we have, and E is equal to 2 into 10 raised to 5. So delta L is equal to 1.5 mm from this equation. Next, the most important thing, that is a circular steel bar 3 meter long uniformly tapers from 50 mm diameter at one end to 25 mm diameter at the other end. Find the magnitude of force which will deform the bar by 0.8 mm. Take E is equal to 200 GPa. This is our tapering section. The dimension over here, that is diameter at this side is equal to 50 mm and this side is equal to 25 mm. So this is called as a D1 and this is called as a D2. The length of this bar, that is 3 meter, and here compressive force, axial compressive force, that we have to find out. So E is equal to 200 GPa means 2 into 10 raised to 5 Newton per mm square, and the elongation means contraction 0.8 mm means delta L is 0.8 mm over here. So whenever we have this kind of tapering section, then what happening? We have the equation for tapering circular section, that is what is the equation? Delta L is equal to, do you remember that? For PL upon pi D1 D2. So equation for that, for PL upon pi E D1 D2. So here E is equal to 200 GPa is equal to 200 into 10 raised to 3 Newton per mm square. D1 and D2 we have. So we are going to use the equation, that is delta L is equal to 4 PL upon pi E D1 D2, and delta L is equal to 0.8 over here. So 4 into P, that we have to find out, into 3000 is length, pi value of pi we have, E 200 into 10 raised to 3 into D1 into D2. So we will get P from this equation, that is 52,359.8 Newton. But whenever we are going to convert it in kilonewton, that is P is equal to 52.36 kilonewton. So these are the case of simple stress and strain. Now in the next lecture we are going to start examples on superposition, and that we have understand in our previous lecture what is superposition, right? In that we have to remember the equations for the compound bar. Delta L is equal to delta L1 plus or minus delta L2 plus or minus delta L3, that we have understand. So this is our simplest examples that we have to used in our deformable body. Okay, thank you very much. If you have any doubt, you can contact me. Mos, subject is very much important for whole civil engineering, especially for structure engineering. Okay, it's a very basic subject, and all of you must have to go through whole subject. Okay, so thank you very much.